Let's do it.
Okay.
Beautiful.
Awesome. Well, we're getting pretty good at this, guys. Thanks for joining us again for another exciting Baseline Tech Talk Tuesday. This is episode 11.
Right.
And as usual, if you are joining us for the first time, you can catch all the previous episodes on the YouTube channel. And the handle is Baseline Web Training, all one word on YouTube. And Dan's pretty good about putting these up within about 24 or 48 hours.
Right.
So if you do know someone that missed today's, you can have them catch up to it in about 2 days from now on YouTube. And then also as a reminder, if you know a friend or colleague, associate that you would like to invite to Tech Talk Tuesday, this is one of our missions this year, is to build the audience and make sure the people that are already in our audience know about Tech Talk and they can join us here today, and to add some new people that can learn about our technology and the benefits of it. So before we get started, let's just do our quick introductions. We have Chris Wright, VP of Sales for the Baseline brand, Dan Conger, our training manager, and myself, Andy Humphrey, irrigation technology consultant. And today we are going to be talking about solar, which is something that's unique to Baseline, fairly unique to market, and something that is oftentimes not known or forgotten about. And so we hope today that we can introduce you to some new technology, some new opportunities that maybe you've heard before, you didn't know enough about, or it could be brand new information.
Right.
So with that, Dan, why don't you lead us off?
Cool. Okay. Well, yeah, you're right. This is unique. And there are certain applications where this is really the only solution for you. And my goal is to prevent people from using battery-powered battery packs out in the valve boxes, right? Because when I was a contractor, that was the worst thing as far as water management was going out and changing those. You would do whatever you could do to leave them alone, right? So, and then of course centralizing it and bringing that information, and we still want to have all those same great things that we have about Baseline controllers and the Baseline system, but we want to do it on solar or on DC power. So I've got a couple images I'll share with you. I think I want to start off with where do these really fit in? And it may be pretty obvious, but roadways and medians, departments of transportations are great places for them. It's challenging to get power out there, or maybe you're never, ever going to get power out there. That's a prime example of that. The other one that I think fits in is construction projects. So when I was a contractor, we would always be in front of when the power phase. We got to get our plant material in because you're not getting paid till you're done with everything. So get the plant material in as soon as you can, and now you're stuck manually watering it, right? So the sooner you can get your irrigating, the better it is. But maybe I don't want to put in a temporary system. I want to do this in. So, that I think we kind of got the medians, Department of Transportation's, county, cities, construction powers. Oh, and then the other one was lead sites. So high level lead, this would fit in really well because we're going to be using solar.
Yeah, lead as in leadership and energy and environmental design versus just being a leader.
Yeah.
And, I think, Dan, what's fascinating is you and I the three of us didn't really spend a ton of time before this sort of prepping and what are we going to say? We're kind of going more organically over time and transparently. And I find it fascinating that the two types of projects that you mentioned here are two similar type projects to the ones that I've worked with. And I haven't worked with a whole bunch, but one of them was a city medians in a town outside Chicago. And the other one is a new construction project at the University of North Dakota where they weren't going to have power until, a long time down the road. So it's just funny that the two use cases you brought out speak directly to my experience.
Yeah. And it's interesting too, because I've had experience not only in transportation for roadways, but also for light rail or
that's good.
Light rail stations where they've got limited power, or the point of connection isn't near a place where they've got power dropped. So sometimes you can think a little bit outside the AC power and find some great projects where this is applicable.
And with lots of cases, you could get AC power to just about anywhere, right? It's just a matter of running underground or running poles. But the challenge is, right, what's that ROI? When is it worth doing? And when is there, so you could sit down and do a cost evaluation, but ultimately we want to have it connected and we want to have it, we want to be able to bring the information and just make it convenient to do that. We don't want to be a big deal to get that information and to have that control there.
Yeah, I think Tracy was trying to photobomb our episode today.
Yeah, that's because I think he was still on as a panelist, and he was like, "Whoops!"
Oh.
Realized he was walking through the back of the show.
Yeah,
whoops. So I do have a couple of examples of installations out in the field. So this is actually a pretty good example of what it looks like for an installation, right? So this one, we've got a stainless steel pedestal. There's the solar panel, and this one actually has an Ethernet radio on it, on its communication. And then somewhere in there, there's a battery that's going to be fitting in somewhere in the bottom. So there's a deep cycle battery that can handle a lot of discharge and then recharge, right? Because that's a traditional car battery would kill it really quickly. So.
Yeah. So oftentimes, when working with these projects and quoting them, there's a bit of a shock because it has to be in a pedestal, right? And the pedestal is necessary to house the battery, unless you want to build some other container to house the battery in for a wall mount application, not a Walmart application.
You could put them in a Walmart too, but yeah. That's actually a really good reminder. Is you always are going to have some place to store that battery, and if it's just to protect it or to protect it from vandalism. The other thing that when we were looking at this picture, that pedestal, that solar panel, it looks kind of short there. And part of what comes with the kit in this case is the controller and the solar panel, the mounting and all that. That's not included, and you need to figure out how to locally source that and get that installed. So there isn't a specification for the height of that and where that goes. The orientation, that's going to be significant. We'll talk about that in a moment. But as far as the height, now this is on a military base, so that the odds of it being damaged are slight, but that would be a consideration to take. Is your solar panel protected from all sorts of potential issues?
Mm-hmm. I do like the fact that mounting pole has dual purpose there. That's pretty unique, that it's also serving as the mast for that Yagi antenna, as well as to hold the solar panel itself.
Right.
Yep.
That's true.
So let me just reemphasize that, when you buy a solar package from Baseline, you'll get the controller, right? And you'll get a panel and you'll get a mounting bracket. Mm-hmm. And we've got no specification or details associated with the mounting of that panel, because it could vary from site to site. Right. And based on the aesthetics or the vandalism, abatement, whatever that is, it's up to the owner to determine how that gets mounted. And so you won't see that directly specified when you're ordering a Baseline solar controller.
Nice. Mm-hmm. So let's get into the what, and I think the what and the what's different. So I think a good starting point for that is our DC controller technical spec. And this is a pretty good overview of the product and the offerings on this one. And I'm going to start off I wanted to talk about what was different, but let's talk about what's the same, right?
Yeah, that's a good point. Let's start with what's the same, because it is much easier than you may think by design. And I'll let you go, Dan, but I think that's a good idea. Let's start with what's the same.
So if we look at the first panel, it's the same base station 3200 that's going to run on DC power. It has a different power board on it. The same base station 1000, the same AG 1000, the same substation, the same flow station. Controllers are identical. They're just going to be having a DC power configuration in it. That's it.
Yep. So it's available across all platforms. That's the important point.
That's the shortest way of saying it, Chris. Yes. Yep. I use many words on my explanation, Chris. It's like to the point. How about the devices that go out in the field? Well, the two devices that are the most different well, I'm trying to go the same, but the two vices that are the most different are the bicoders. So we've got a single zone DC bicoder and a 2-zone DC bicoder. All the other sensors, the exact same sensor. It's not even a different designation. The same flow sensor, the same pump start relay, the same soil moisture sensors, coaches, but all that is exactly identical. So those two bicoders are unique and different than the others.
Why?
I'm supposed to know the answer, aren't I?
No, it's simpler. Chris is not trying to stump you, right? He's trying to bring out what we're working with here, which is, again, it's a DC powered system, right? So the consideration that you want to remember when you order your valves from your suppliers, they will need DC latching solenoids, which seems very elementary. However, can be forgotten. So that's the main difference, is they're latching, right? There's not constant power. They latch on, they latch off. Right? They latch on, they latch off, and you can switch out solenoids, or you can order your valves with DC solenoids, depending on the manufacturer where you get them, so on and so forth.
So as for my installation days, I could tell you if I would have ordered 50 AC valves and then had to pay an employee to sit there for a day and to change out those to DC latching solenoids and then potentially cross thread and screw some of them up and then go back and buy some more, it'd be really annoying. To Andy's point, if you could just order them with DC latching solenoids to start with, that would be just a wonderful thing. So to answer Chris's very specifically, we've got a DC bicoder and we need a DC latching solenoid to go with that DC bicoder. Then it's connected up and it'll be just as normal.
Yep. Okay. And keep that in mind also with your master valves, right? So it's quick to think, the zone valves, but if you're using a master valve, it would also need a DC latching solenoid.
Yep. Oh. And you keep mentioning these DC bicoders, right? So is this functional with conventional wire as well?
Excellent question. And that was kind of going through my head too. No, this works with 2-wire. We haven't, it won't fit in with the powered bicoders or essentially conventional wiring. So this is only a 2-wire system that we're talking about. And it's really probably more about voltage drop and the resistance on the wire. And so the two wires is the short answer.
Yeah. And that's sort of why I think, Dan, when you spoke to the use cases in the beginning, mostly new construction. Yeah. Right. Because conventional wire tends to be a retrofit application more so than new construction.
Yep. So if a client has a roadway median where they have a bunch of battery operated controllers installed with conventional wire to the valves, and you wanted to retrofit that to solar, right? Then they would have to run new wire to each valve location. Correct?
Right. Which would essentially turn it into a new installation. Yeah.
Yep.
Yeah. Mm-hmm. Now, what would happen if they had AC power and it went away? Well, then we could change the bicoders and change the solenoids, and that could work as well. So, okay. So,
all right. So you glanced off that.
I know. I did it.
Construction scenario, which you brought up first as a use case, right? Then you may switch to AC power in the future. So, do you have to switch the bicoders? Let's come to the AC power
construction scenario. I've put in the DC controller with the DC bicoders and the DC latching solenoids on the valves. Power comes in, and I want to move my assembly down to the next phase. So in that case, I would need the bicoders would stay. I can use a DC bicoder. I would change the solenoids back to an AC solenoid, and then the controller, I'd change the power board basically to convert it to the power source. I can leave the same controller. So I would now have an AC power. I could still use the same DC bicoders and then back with an AC solenoid. So
what Dan's trying to tell you is that the DC decoders can be used with AC or DC. But our standard AC decoders
leave it to me, right? I'm going to go as technical on this one as I can, right? Short. There we go. Thank you, Andy.
Our DC decoders are AC/DC.
Oh man, we need a soundbite on that one, don't we?
Yeah, I know. I'm thinking Back in Black. Yeah, really good.
We so missed it.
All right. Okay. So just to reiterate, If you go to AC power, you don't need to change the decoders. You just need to change the solenoid.
Yes. Yep. And then,
or if you've got some job leftovers and you're a distributor on this call and they're DC, you can use them on an AC system.
That's true too. Yeah. Yeah. A good point. Okay. So the hardware that goes in there, other than that, it's pretty much the same system, right? We can use the same communication modules. We could use radio, cell, Wi-Fi, Ethernet, whatever we've got that works even on a DC system. So that's cool too. So then let's talk about some of the considerations that you might have on this one. So I'd say probably this on the middle one, it says calculating battery and solar panel needs. I'd probably say that's probably one of the single biggest things to take a look at. And we have a solar calculator worksheet. And there's a lot of information that goes into this one. And this will help you understand that you make sure you get the right size solar panel and that you have the right storage capacity for your system, the way it's going to run. Because a 5-zone system in southern Arizona, that's going to be work completely different than a 50-zone or 75-zone system in a cloudy environment that doesn't have that.
Powering a pocket park with 6 zones is different than 150 zone, streetscape.
Absolutely right. So let's see. What are some of the things that come on this sheet? So first one is, what's the controller, right? How big is so once you grab that, right, the transformer size and the demand from the processor comes in. Then the communication devices. Those different communication devices add down to the draw that's going to be using. So if I have a switch that I'm going to be sharing it with, and all the different devices that are going on there, and then that goes down to the load requirement, and then we're going to pull from another location. There's a federal site that kind of shows the solar radiation, and we can kind of pull that information in. Ultimately, we come down with 2 things: how many solar panels do you need, and how many batteries do you need?
Yep. So. Yeah, and based on the solar panel that we provide as part of a solar package, it's an 85 watt panel, but there are panels available, from multiple sources, that aren't expensive on the web. So you just got to make sure if you're providing your own panels, then you need to make sure that it, fits within our specification and will provide enough juice, so to speak, so that the system will operate as expected. Right.
Because we're not, it's not really about the solar panels for us. We're just doing that to make it convenient and work for you. If you got another location for that, and as it is, the battery you're going to have to source locally anyway. And we're not going to ship a lead acid battery across the country. That'd be,
yeah. And as another point, if you source the panel from us, then we will support the panel that you sourced from us, and we will warranty the panel that you sourced from us with Baseline's warranty. If you go third party and provide your own, then you need to get support from that panel's manufacturer, wherever you got it from, if something gets sideways or goes wrong.
Right. Yeah. So something else that came up was the wire that goes in the ground. So we said we started off with saying this is definitely 2-wire. So wire runs are going to be shorter, right? We don't have the wire spec is shorter, and that's also on our technical specs. We'll talk about the wire. So that's an important consideration to have as well.
So as a rule of thumb, if you look at the specification, we half the wire length run and the device load capability associated with the solar powered installation. So, but that does not always mean that it is going to be spot on half the load, because there's a lot of variables that come into play. One, how much juice your panel provides, how much power your battery that you sourced is able to store. So there's going to be some variability, and you should expect that. But if you use the calculator, it's going to get you within the ballpark so that it will perform and function as expected.
Good. Nice. So
yep. And, you talked there about loads, and that's something that we haven't talked much about because it isn't as much of a consideration as it once was. So 10 years ago when all of our devices had different loads and you thought you might be using 200 zones, you had to do a little bit of load calculation to decide how many, maybe 4 station, 2 station, 1 station you might need to mix in order to keep that load down. And it's less of a consideration, but it is a good reminder that all of the components have a load to it that contribute to that wire length distance based on how many devices you're trying to fire or communicate with.
All right. Should I quiz you guys? See if you know your loads. So
I've got my load chart up. You can't on my other screen. So.
You got a cheat sheet? Oh, is it up on screen?
No, I'll put it up on screen so you all can see it. So then you don't have to quiz me, and I won't be embarrassed.
Valve decoders are half a load. The soil moisture sensor is 1 full load. A flow bicoder is 3 loads, right? So you need to consider these things, and that all plays into the wire gauge and the wire length, and then the way it's programmed and how long those various devices are operating. That's going to create a power draw on your controller that could impact the performance of it.
Now, I don't have the newest chart up. This is actually one that I took from my installation trainings. I don't have the pressure bicoder on there. Is that, I think it's the same as the flow bicoder?
Yeah, I believe so.
Yeah.
3 loads.
3 loads. Okay, nice. So then this is for a standard AC installation. So DC would be half of that load. So we're saying 110 device loads. So 55 device loads would be the maximum you'd use on a DC system.
Yep. And again, if you have, because we can do 8 different water sources, you could have, 8 times 3 loads for flow. Right?
True.
8 times 3 loads for pressure, 25 soil moisture sensors. It does add up if you are considering a large system with lots of different devices and components.
Mm-hmm. You can still use those devices, but you have to be more aware of that. Where you're right on an AC system, it's rare that people come across it. It's not. Let me rephrase. It's not as common, but you could hit that ceiling on a large DC system. I could see that happening.
So I think Jeff Hume hit it on the head when we were joking about AC DC. He said DC decoders on an AC system, those are dirty deeds done dirt cheap. That was clever. Huh?
Yeah,
quick on his
feet.
Good reference there.
But it bodes the question, and it's come in a couple of times. Why don't we just add an inverter and use the conventional decoder offering from baseline, rather than going through the hassle of trying to fit the two? Or
well, I think it's still the latching part of it. I don't think an inverter converts it to latch. It's still holding open. I'm not entirely sure, but there's some functionality difference, I think. Speaking from someone who doesn't know, just
right. And again, I'm going to spitball on this one. If the question is why not run an AC controller and AC bicoders and AC solenoids with an inverter on there, I suspect there's a significant voltage or a power loss when you're inverting. Yep. And that's probably what that's about.
Because I think it's still a constant. You're still holding that solenoid open all the time. It's not it's not a latch.
It would have to be
on off, right?
Yeah,
that would be my guess.
Draw your power down faster,
right? Because you could run your computer, you could charge your laptop off an inverter in your car, but you got plenty of juice in your car.
Right. And I've got something to add that again. Let's see. I believe I've heard this before. There are other systems that are DC operated 2-wire systems that have had historical trouble, right? So that if you latch your zone open and then the controller loses power, there's been instances in the past where that zone wants to stay on. And if I'm not mistaken, if you think of our decoders as smart decoders, there's a capacitor in there that holds enough power to close that solenoid on its own without the controller. Should the wire path be cut, et cetera, there will be no stuck valves in that open latched position.
Yeah, that could be if a car mowed down a pedestal and you're irrigating. I could see that latched open.
Yep. Excellent. All right. So just a follow-up question. Someone wants to know if the soil moisture sensor operates the same under AC versus DC.
Absolutely correct. Yes, it does.
Correct. Yep. So, and all the programming capabilities are the same. You can utilize the same lower threshold, upper threshold watering strategies. You can do the same water management, monitoring, and shutdown and management. So the functionality of the controller is the same. It's just on a bit smaller scale, depending on how much juice you're able to generate from that solar array associated with the controller.
Yep. Right. And Scott asked a good question about two-way communication. So as Chris just said, it operates the same. And again, the two-way communication, or just thinking about our two-wire path as a comm cable, is really also where the load and distance specs come into play. And so one of the first signs of a system out of spec is the controller says can't communicate with the device. You turn on the zone and you call me and say, Andy, I see the zone's on. It's watering. Why does it say can't communicate to this device? And oftentimes that's because that zone, the system's out of spec. Signal hits the decoder, but it's lost on the way back. So you can turn it on, it'll operate, but it doesn't have enough to come back so the controller can read it. And so that communication all plays into the specification.
Okay.
Yeah. Okay, so as we're winding down to the end of this episode, you mentioned, Dan, early on that the substations and flow stations will operate with solar, right? So as I think of that, I'm like, okay, where would I use a substation solar scenario? And it may be associated with a remote water source or point of connection you can't get to, right? So there may not be a power drop out there. You can install a substation, wire up that water source or control point to the substation, have it solar powered, and communicate back to a conventionally powered 3200, right?
Right.
All right. So if we were to take that next level, what would that look like? Speaking of those small...
Well, a substation can handle 100 zones. Yeah. So you're talking about a scenario where I've got 1 to 3 zones. Yeah.
Right.
Yeah,
or no zones, as Chris just mentioned, just a communication path, basically.
Yeah.
Exactly. So this solar capability is going to come into play in a bigger way for us as we bring to market the substation RV, which we have alluded to previously, right? Which will help bring a lot of those remote valves and potential battery operated controllers on conventional wire into a 3200 configuration using the substation RV on solar power with conventional wire on those 4 zones. So a little bit of a deviation in the technology, a little bit of extra engineering into that, that I think is going to be very, very helpful and applicable. So we'll get you more information on that as it comes to market. We are about to start our beta test for that. And I know several of you are excited for that and wanting it. So we're interested in your feedback on it. So awesome. All right. Well, we burned through a half hour.
Yeah, who knew we could take 30 minutes on solar? That's great.
I know, right? Exactly.
You've obviously never spent a night out with us.
We still didn't see Dan's guns.
Ain't gonna happen.
It ain't gonna happen. All right, what do we got on tap for next week?
That's a trick question. Next week we're taking off. Spring break week.
We're gonna be in break week. Woohoo!
We're gonna be in Miami Beach in our. Never mind. I'll just leave it there. We will be back the week after that, so that'll be on April 6th. We're gonna talk about base manager maps, setup, maybe some tricks and the hacks.
Cool. All right. Well, we had great attendance today. Appreciate your participation.
Yep. Tell your friends. Baseline Tech Talk. Let's get them on here.
That's right.
Let's goal. Grow this audience.
Our viewership. Yep. So thanks again, everybody. Go out, work hard, be safe, and we'll see you back a week after next. Have a great one. Bye.
Take care, all. Bye.